something I always wanted to do, and that's check out this awesome chip tester and hook it up to the VCR directly. But I need to check what I'm doing, so that's why I took this cool radio cassette recording thingy. And it looks like it needs a new cap for vertical deflection. Ah, there we go. That's brightness. Anyway, I need to set the clock again because that's not quite right. So that's... Yeah, I'm wearing the fancy pants, the magic vintage fancy pants from Curious Mark. And thanks to those, I fixed a lot of stuff today already. Not even kidding. Okay, so that's what we're testing today. Well, no, that's not what we're testing today. That's what we're testing with today. So this thing can test chips in and out of circuit. So for example, this board, there's a 6502, and it did not get a clock signal in, and that came out of this chip. Oh wait, it was on this board. You can see it's already been replaced. And the oscilloscope got me a mid-level with no signal on it for the output. So this is what it says. Now I can press accept. I'm pressing it out of circuit. Now I can put this known bad chip, and there it's known bad because I've tested it. And also the oscilloscope said it was really bad, but sometimes you just don't know. Now you key in 7474 and hit run, and you can see. Yeah, setting the camera to do this doesn't really do it a big favor. So this thing is bad, and while we're at it, let's test a few more. Already bent the pits. Oh wait, that 367. Does that work? I think it works. Let's see. 367. What? Oh, wrong button. Oh, there we go. Yes, that's what's bad. This was what made my pinball machine not work, and it passed in circuit. How about that one? It's a 157. 74157. 74157, and it's completely shot. Also, the enable pin is shorted to 5 volts. You can try to burn out that short circuit, but what else? I've got a truckload of bad components up here. That one's got a pin bent out to make sure I don't use it. That's a 4028 here. How does that get here? And it's completely dead. Why am I even keeping it? I mean, look at that. This is a Christmas tree of errors. Everything that's lit up here is an error. Everything, if it's black on green, it's an error. And there's a 7401. I'm pretty sure this one's okay. It isn't. Maybe if I put it in the right spot. Let's try that. Yep, look at that. This is what a good chip looks like. Now you know that. You get a pass up here. So, but the real beauty of the machine is you can test in circuit. You'll be getting a lot of errors as false positives. A lot of false positives you'll be getting. Also, you need the 5 volts. More often than not, I abuse this machine as a 5 volt power supply and use the scope, but so okay, we need to find the ground and the 5 volts. So it says it right there. We have our ground and we have our 5 volts. So That board is now drawing power. Yeah. 0.1 milliamp. Nope, that's 0.1 amp. That's actually, no wait, no, that's not true. It's 1 amp. It's exactly, it's times 10 amps. So actually the power supply never exceeds mid-range. So 5 amps is the maximum this thing can put out. And you can also see the screen shrinks when it's fully loaded. Also, you can see the screen shrink if it accesses the floppy disk. So okay, this thing is now hooked up. So what we're gonna do, we gotta set our mode. Set our mode to loop, because we will be getting false positives up the posterior. We will not be able to test these because they need 3 power rails, and also I've checked them with the oscilloscope and they're fine. Also, we will probably not be able to check those because there's a wire clipped to them, but we can try. Also, the legs are really corroded. Yeah, that's another thing you need to watch, because that will also give you false positives. What also sucks is I don't have an active microphone, so once I switch that screen over to the VCR, that's why I have this cool old thingy here, is I can't say anything anymore. So, too bad we can't check these. There's a decent chance that, no wait, sound was working. No wait, sound wasn't working. Nothing was working. What am I saying? Nothing is working. There's a decent chance one of these is bad. So, okay, so if we're getting a chip that fails, what do? We check the same chip on the other board and see if it fails in the same exact way, or a very, very similar way. Yeah, same board, just different colored wires. Okay, and then we can check if that does it. So, okay, let's just plug onto a random chip. It says 74175. It's not even an LS, so but it looks good. Now the test links and the pins are perfectly aligned, and we're getting a pass. Now we have them floating there, and short is 5 volt. So this thing is always enabled or something, or never cleared, or whatever that pin is. I know it's quad flip-flop. Do we have any other 175s on this board? No, we have a 157. So I'm right now checking if there are any more of those. And it looks like no, so we can stop that and go to the next one. Let's say that's a 00. And it says it has no ground. Okay, now we're getting input signal changing continue. And that was a sporadic signal from a bad contact. And yeah, you can see it sometimes fails. Yeah, this is just not a great connection. So, yeah, do we have any more 00s? Yes, there is. So let's unplug this, and you can see no supply on the screen. And we have another one, and that is also passing. We're just hunting now for bad components, hoping that I can find one that behaves, that gives out an error. And there's another 00 here. And it's, wow, look at these legs. Look at these legs. They're rusted and tarnished, so there's a decent chance we won't be getting zip. Well, actually this is not looking so bad. Look at that. It's passing every now and again. And we can get it to pass solidly. It's a solid pass. Okay, that's one thing you've got to check. So, 7404. We got quite a few of those. So, and even from different manufacturers. So here's one. And it's passing. We got a signal again. And here's one from Texas Instruments. That was National Semiconductors. Yeah, we don't have awesome connection there, but we sure have some happiness. Let's see if I can test this. There's a botch wire soldered to it, and it passes, even though there's a botch wire attached. Okay, you know, let's keep hunting. Let's start doing all of them in order, and I'll hook you up. Which will be awesome, because this screen is actually bigger than this screen. And I have this screen duplicated on that screen. But you know what? Look at this. This is a test setup. That's a good old Philips Chrome monitor. I just thought my VCR was turning off, but look at that test setup. So let's first try to fix the board, and then we're gonna go over some of the features of this machine, which are just pure awesome. The manual is in German. Ah yeah, this is just an in-circuit chip tester. It cannot test outside circuit, and there's no floppy drive. Oh, by the way, guess when this thing was made? The floppy drive is a hint, because it's a 3.5-inch double density. I guess it's single-sided. I guess, I don't know. It says something like 260 kilobytes capacity per disk, in a format that can't be read with anything, except for this machine, of course. Anyway, the 3.5-inch disc is a giveaway. This thing is a lot newer than it looks like, because it looks like it was made in 81 or something. Yeah, it was made in 87, 88. It's been upgraded. Firmware has been upgraded in 88 or 89, I'm not sure. Okay, but let's see if I can switch you over. Unfortunately, I ran out of BNC connectors, and I only have one of those. And I need an alligator clip and a resistor or something to get you. That sucks. This thing outputs 60 Hz video signal, and this thing can only record 50 Hz. Yeah, by the way, this is a Panasonic. That's a Panasonic. I got 3 of them. One's branded Bosch, the second's branded Grundig, and the third one was branded Blaupunkt. The first one I actually sent off to Dr. Cassette, because he has 2 of them and none of them is working, and I have 3 of them and they're all working. So I thought, you need a working one. You'd sure love a working one. So that's what but this is what I was talking about, you know? we have three identical chips here. 3 identical chips. They all do the same thing, they are the same part. This one fails and these 2 pass. So, what did I do? This is the known working board. And it fails in exactly the same way. So that tells us this chip must be good. Or at least there's a really, really decent chance this chip's good. So, we have to test on. Also, I will have to film off the CRT. Let's get down the contrast a little so it's a bit easier on the camera. Fail is still very faint, and you know what's weird? My eyes barely see this thing is on. And this awesome grounding here, ground lines here. Okay, so let's continue. Hey, wait, there's 3 more. It says there's no supply win. Look at that, it's passing. Oh, we're on the working board. This one's failing because it doesn't have a good connection on it. Because see that? Pass. No, it's not too dim. Yeah, it's better. At least I can now see it. Also, another thing is, maybe you can't get it to pass, but if this portion, this is failing now, and you jiggle it, and it starts passing, and another section starts failing, that's also a decent hunch that this chip's good. So let's go over to the next one. And this looks very, very good. It is. Passing. Here's a 3rd one. And that looks okay. Hello. I know you're good. There we are. And we're bad again. Ah, it's just passing for a fraction of a second. Yeah, the legs are tarnished. They're not making good contact. Yeah. There we go. So, do we have any more of these? Actually, we do. These were all Fujitsu's, so they must all be bad, of course, because they're Fujitsu's. I don't know what your problem is, but I didn't have them fail any more often than any other component, except maybe Hitachi's. These next to never fail. I had I had one day where I had 3 Hitachi's fail. It was like the same amount of failing Hitachis I get per year for that year. And when I hold the probe just right, it's working. It's not on right. I can't get it on. It is on. It's drawing power. And here we go. Passes. And this one passes too. Nice pixels. Any more? Yep, here's another Fujitsu. And it's passing. Color me shocked. But okay, we have any more 3, 6, 7s. 42, 42, 40. I've got to edit that out because that's gonna be boring. So 2, there's no way to see what that is, but it's the same component as here, and it's a 112. So I gotta memorize that because Hey, there's another one. It says LS36, but there's a very faint 7 here. Here's another one, but we haven't checked these. So, let's go through these. What's this? This is 74 something. Also not readable, but it's another 74. Okay. Here's where we deviate from our plan. This is the same part number from the same batch probably as this one was, and this one was bad. So we are testing this guy. Yeah, okay, it passes. So back to our 367s. There are no more of those. There is. Output conflict. Interesting. And look at that, it's completely dead. Okay, so let's check these two. They're the last ones. It's exactly as dead. And this one passes. Okay, you know what? Let's go back to this one and jiggle it some more. And guess what? I'm gonna do the same on this one because it had very tough. Look at that! Look at that! It was just failing. It was just failing like crazy, and now it's passing. So let's go back to this one and see if it passes now. Okay. No matter how much I jiggle, I can get. You can see the floating and high impedance there flashing on pin 12. Oh look, there the link A went away. Okay, but this is this is another time for a board. This calls for a board swap. So we swap the boards. Talking about some of the cooler features of this tester later. God damn it. Now look at that, it's passing. Okay. That chip's gotta be bad. That chip's gotta be bad. That says link A and link A. So the pull-ups are connected. Actually, these two, I was getting an output error on these two pins, which are the enable pins for that chip. I know that. It's basically a bus driver. It's a tri-stated component. It's much like a 244, but it only has 6 gates. So I was getting it. So maybe I couldn't enable this drive. So there's a good chance the chip driving this chip has a short circuit. It could be a short circuit on the board, or it could be that this chip is totally borked. Got the desolder pump running already. Also, it's getting time for dinner. But look at that. Isn't that sexy? I like it. Ooh. That sucks. I can only focus on the monitor or the circuit board. And the circuit board will be blurry in the monitor no matter what I do. I can see there's a distinct lack of vertical amplitude, so probably bad capacitors. Who cares? This entire thing is a bad capacitor. If I try to play a tape, it hums like hell. Oh no, wait, I can play tapes. If I record them, it hums like hell. But then any sane person would avoid recording using this machine unless their life is threatened if they don't. I'm a crazy person, I do it anyway. Never mind, the output error is gone, and the chip is just as dead. So, I'm gonna put it out. Now, with the chip out of circuit, it's clear that it's dead. It could be just because, you know, it's not even doing anything. If I remove it, if I put it back, nothing happens. It's absolutely 100% dead as a rock. I could give you that 376, or what was it? No, that's a 174. That's something else. Whatever. I'll give you a new one. Or a new old stock, probably. I mean, I buy them new, but I still get ones with date codes from the 90s or sometimes even the 80s. I remember going to a local electronics store. Rest in peace, they don't exist anymore. And 367, and they had only one chip in stock, only one piece of the chip that I needed. It was new old stock, never used, 1972. It worked. It got a bit warm, but it worked. So, there's two things you could do. Either you head back to the machine and test if it's working now, or you can carry on testing. That's actually what I'm gonna do. I'm gonna carry on testing. But there's one thing. This is a Deco cassette system. I'm making two separate videos. One is the Deco cassette system video, and one is the chip tester video. So those who are only watching the chip tester video, you might not know what I'm testing. Well, I said it. I'm testing a Deco cassette system. Yeah. This is where the dongle goes, and this chip is right next to it. So you know what my guess is? Somebody has swapped the dongle while the machine was turned on, and that killed the chip. Either this, or it's one of those Fujitsus that actually do die. Because you have several bad batches of those. Several bad batches, but look, these are all working fine. These are all working fine. These are working fine. There's like 8 on each board that work, and they work fine. And sometimes I get dead Fujitsus that die of something else, like it looks like an internal short circuit or contamination of the output transistor. Anyway, you get outputs that are floaty with trash on them. You can clearly see that it's trying to switch, but you know, on the output of each chip you have a push-pull amplifier, and it's like one of the transistors is shorted and the other one's trying to pull it its own way, and it can't. So yeah, it's a failure mode. Yeah, anyway, okay, let's carry on. So here's a bank of 194s, and I won't test these, and I'll tell you why. They're hard to test. You know what, let's test one of those. Need to look the board back up. Gotta test one of those. These are pixel pushers. What they do is they read out the RAM and push it to the screen. They're pixel pushers. They're taking a byte and serializing it. And since our screen looked perfect, we know these are good. So, I only need to test one. And look, it's failing. Ah, it changed. And now it passes. Okay, so maybe they're not that hard to test, but they're still their shift registers, so the test is quite long, and if there's a bad contact while testing it, the tester will end up in a state where it might end up in a state where it'll never pass. This is if you're testing counters or shift registers, that's a problem you'll often encounter. This thing will end up in an endless loop where it will just never pass. You have to in that case you just have to push the red one and the green one again, and either this or reboot the entire machine, or
the chip is really bad.
okay, I'm not gonna test the others. So 157, we got 157s, and I know we have more than one of those. And it's failing too. So let's jiggle, and what happened? Oh, input signal changing, yeah, sure. Oops. I don't know if you saw that, and for a fraction of a second it was passing, and then, yeah, it's back to passing. We just have a bunch of bad contacts, so searching for 157, and this one's passing too. I know I've gotta take a break because we're ordering pizza. Already tested all the 7400s, so now the one. Now we got the 138s. Wow, this looks terrible. But look at that, I'm jiggling it and gets better, and now it passes. Okay, this was a Hitachi. And here is another Hitachi, which is also really, really crusty. And you can see it's getting better. Oh, and it's passing from time to time. You can see that. It wasn't so much out of focus, and that pass. Okay, here's one from Texas Instruments. Wow, just completely dead. And now it's half flow. Let's go one more. And look at that, and it's passing. And I know there's a few more. I thought there were a few more. Let's go along the row, and there's another 138, also Texas Instruments. Remember that Atari I fixed lately? I had a row of 191s, and there were 5 or 6 of them, and there were 4 different brands. Like, what the hell? Okay, so there's 4, and there's 2 different brands this time, and there are no further ones, and also the 7404s are already checked. So now the 7442, this one's of course completely garbage because it's a 138. It's actually more or less the same chip, just with a different pinout. And there we go. Pass. Do we have any more? I know we have more. I know we have a ton more. Look at that. There's another one. TI. Rusty legs. Rusty legs, rusty crusty, and it's actually good if most of them are high. And look at that, it's passing. Let's see if there are any more. Nope. Let's go here. Oh, that one just passed. And that one passes. That's a 32. 0202. So we're done. That's a 245. These 3 have been, there's 374, so I'm gonna check those later. Okay, we are now at, there's a 7410. Might be the only one here. And it's okay. And indeed it looks like it's the only one. Okay, so we be going to the 153s now. Giving these a check. These are highly likely to be the RAS-CAS generator multiplexers for the RAM. Highly likely. There's 4 of those. So yep. Looks like kicks again. So pass. Oh wait. Do I have that screen on? The screen. Yeah, I do. Pass. Yeah, it's working. And here's the, I think it's the last one. It just passed, and now it fails. It passes. And yeah, that's it. So 7404. This is 7408. I haven't checked this one. Let's check this one. Come on, I know you're good. Look, this one pin won't switch to low. Okay. Let's switch it one over, and look at this, it's still low. This chip's bad. This chip is bad, it's not outputting low ever. So, since this is an AND gate, so both inputs have to be high. Both inputs have to be high for the output to be low. Although in floating this is easier to achieve than what you think. And yeah, it looks like it's high most of the time. So let's pull it off and make sure. So let's check the inputs. Floating, and high. That's okay. So what happens if I ground it? So, okay, what is your problem? If I ground the inputs, the output goes low. So this chip is okay. This thing is too sensitive, but why wouldn't it say mid-level? It should have said mid-level. No, it passed! No, it just passes. It's like I insult it and it starts working. Lots of tech is like that. So what is this mystery chip? It's a 112. And it's totally bad. Look at that. What happens if I jiggle it? It's even worse. It's short-circuited to itself. Something else. It's a flip-flop. It's a flip-flop and it's shorted to itself. And now look at that. Now the error is completely different. And if I turn it off, start it again, get the same stuff. And I say this is probably gonna be all right. So let's check what the other board says. And yeah, this is a bit different. It's jiggling there because of jigglies, but I get the same exact fault. If the fault would be different, then that would mean that one of those chips bad. And since we know this board's good, I don't think it is. I'm pretty sure it's working. Okay, let's carry on. Let's go back to the bad board again. Okay, I'm gonna put you down. So okay, that's a 7414, and I can't get it to register. Up. Get it low, get a high, get it working, and it just passes. Yeah, same deal. Pin 4 is a bit iffy. As long as the electrons are going where they should go, I don't care. Now pin 2 is bad, but pin 4 is working, so you get the idea. It's working. It's a good working chip. So what's that weird ceramic? It's a 74245. It's a bus transceiver and it's got rusty legs. Let's see. Well, you know, there's one thing. It's floating. You know why that's why it even says that? It's in circuit, so it expects there's something connected to this. And if there's nothing connected to it, even in circuit, then yeah, maybe you just miswired your prototype and that's why it isn't working. But yeah, that may be a good thing, but probably you don't need that information at all. And here we have a bus conflict. Just and it passes. Okay. Ceramics are also usually a little harder to kill. So there's a single 7406. You can't really test them. There are open collectors. Oops. Also, if you have a 7406 that says mid-level on a pin, that doesn't mean anything if there's no pull-up installed. If there's no pull-up installed, you're getting a mid-level. So this is highly likely a false positive. But it is going low and it is going high, actually. The high is coming from the chip tester itself, I know that. So yeah, this chip's good. This chip's good. I'm not going to check it any further. Hey, look, there's a 32. I haven't checked that one. And there's a 7404 I didn't check yet. So, ugh. Wrong chip. Me and my memory. Me and my short time memory passes. So, is there another one? Yep, it's the bodgy one. Okay, there's a decent chance I won't be able to connect it. Actually, I am. Yeah, passes. So, this guy passes. It's got a few rusty legs, and it passes. So, are we done yet? Actually, no, we aren't. There's another 04 up here, which passes. And these two are 374s, if I recall. Wow. Wow, if you look at it just right. If you look at it just right, you can see there's this 374 latches. Yeah, and look at that. They got a few bad outputs, but if I jiggle it, there's only one bad output, and if I jiggle it some more, it goes to working. And since it's a tri-state chip, I can check that it's not connected to anything. Is kind of weird, but look at that missing connector. I just guess it's not. I just guess it's connected to a lot of stuff that's all deselected, non-active. Otherwise, you get bus conflicts. So, right now, everything that can be tested has been tested. Everything passed except for that guy here, and these aren't tested. So, also I can't test these yet. Well, actually, I have a problem. I have a problem with this thing. I can't get it to test bidirectional ROMs, but components RAMs. But okay, we're done. So if it's still not working now, it's got to be one of these or all of these or any combination of these. But now look at what's awesome. Look at what's awesome. This is an adapter to be able to test a 2101 or a 5101 or a 9101. So this one I already bent the pins up and marked it X, so you know it's bad because this is what the tester said. So I plug it in, out of circuit, to 114. And then it says, oh, 2114. No, it's not a 2114. I say 2101, and it says unknown. I say 5101. Here's the problem. I have a 5101 on there and a 2101, and one of these is the wrong file and it's not working. It's a bad program. So, you heard that? But and now it says busy. This might take a while. Ah, yeah, this is the wrong one. Ah, still in loop. Holding the breakout switch. Okay, so normal. So I go 2101. That's got to be the right test. And this takes a little longer, I think. And I programmed this. How do you program this? Well, you've just seen, let's say, program on the screen. You might have seen the oh, wait, look. There. It failed with the bent out pin being low. I don't know why it's low. It should be tri-stated, but I don't know. Wait a minute. This chip doesn't accept tri-states. So what's the secret? Enter space on external keyboard. No, it's press space on external keyboard. Now look at that. We're in test basic, and we can now load 2101 and list that. It takes a little. No, I'm not gonna. And also, if I push this button, oh, the cursor disappears. So, I can see the cursor is dim, because you can edit lines, and this is insert or overwrite. Yes, it can do that. It's like, okay, I say edit 1055, and then it goes. I can use the cursor keys to go around there, and I can say moo, and it's overwriting the print statement. But if I hit this key, it goes that way, and now if I type some shit in, it's gonna. So let's overwrite print. I'm not gonna kill that. But what's even more awesome is if I run it now, it tells me that it needs an adapter to move some pins around, which this is. And look at that. I got some expected 0 and got 8. So yeah, that's the. And what's even cooler is this one thing. All 0 is done. Okay. I've got an even better test. What? No such file? Ah, wait. I called it soak loc. And there we go. And if you list that, you're busy for a while. Oh, not that long. It uses subroutines. So, and take a look at that. I should have tested it with a working chip. This is basically write 1. This is gonna end up with 9. Yeah, expected 1 got 9. And yeah, it's writing all kinds of patterns, and also it writes to the chip. It writes the entire chip before reading the entire chip, while that other chip reads back what it's written while it's writing. So I think it's Control C. No, it isn't. So let's try Escape. Yep, Escape works. It's just Escape. And actually, this is one of the best keyboards I've ever used, and I've used a lot, including the IBM Model M. Yes. You can also put up a directory. Here's the directory, and even though it's 8.3, by the way, these BAC and PCB files, they're not mine. I don't know who programmed these, but that's what I did. And look, I use quotation marks. It even saves the quotation marks. This is a checksum. This is for just calculating a checksum of a ROM. And there's a, yeah, guess my number program. There's a PAL decoder, which is basically crap and not working. There's a 4-bit dump, which dumps rare 4-bit by 256 chips. There's a 6810, which should work but doesn't. There's a program for the Intel 2125, which is a 1 kilobit chip used in Frogger and Scramble and basically Konami Classic. Also Pac-Man. And there's the 2101 and the SOAK 2101, and that's actually it. And look at that, space remaining 236K. So, unfortunately it's in German. I'll translate it. So, generate a number from 1 to, let's say, 100. What did you guess? What you guess? I guess 50. This is too big. What you guess? 25. Too small. 7. Too small. Now it's like 43 or 42. It's too big. So we're at 40. Divide and conquer. Too big. 39. Yay! Got it. Right. 6 tries. So, is this thing awesome or what? I totally love it. Yeah, that's one thing I forgot is one of the first things I did with it. I had a black screen in Commodore 64, and you know how much a pain in the ass a black screen in Commodore 64 is, because it could be everything. So what did I do? I checked the logic chips with this chip tester, looping, and there are 2 MOS branded 257s, I think they are, right next to the RAM. You got on the Commodore 64 motherboard, you got the RAM, and then there's 2 257s, and they both failed, but they have different patterns. They failed with different patterns. So I got another Commodore 64, and both failed with the same pattern. So the chip that failed with a different pattern, I removed. Put a socket in, put a new chip in, turn it on, and blue screen of life. Worked. That thing just saved me like a couple hours of work. Because the oscilloscope told me all 4 outputs of that chip were toggling. This thing told me they were not toggling right. Isn't that awesome? I love it. I totally love this thing. And so yeah, this thing is awesome. I like it. I hope you do too. The question is where to get them, how to get them. Also, you might not even get those because there's also the DIT-64, and you know what the 24 and the 64 is. If you count the characters per line, I think they're 24. The 64, and you can see screenshots of that online. You can see screenshots of the 64 online. It has 64 characters per line, which on this tiny screen begs the question. I mean, sure. When it comes to graphics, this thing is way behind its time. I mean, this is a home computer from like '78 that had graphics, had text like this. No one would have want to buy this, but this, for what it's supposed to do, it's enough. For what you want to do with it, it's enough. Even worse, it has locate commands. You can put the cursor anywhere on the screen. You can put the cursor on any position on the screen. There's a working random number generator. If I start that game again, it'll give me a different number each time. So the random number generator is working. Also, if you turn it off and on again, it'll get different numbers. So it's a real random number generator. There's only one thing that sucks, is variables are one letter. You can't have 2-letter or 3-letter or random amount of letter variable names. So that sucks. But it has 32 kilobytes of RAM, and guess what? Peek and poke work. So you can poke the RAM in an array. Yeah, 32 kilobytes of RAM. I don't even know what CPU is in there. I had it open, but I still don't know what CPU is in there. I checked all the chips. I checked all the numbers on the chips, and I still don't know what CPU is in there. My guess it's 8 bits. Something 8 bits. I like it, it's awesome.